Hello, my fellow gnomes, and welcome to part 3 of our tower defense series. And this is an action-packed episode, as you can see, because we're introducing some new mob types. We've got some animations going on, and our game is starting to come to life. So, if you want to find out how I've done this, then keep watching, and I'll show you how. We're going to get rid of our just boring zombie, and we're going to add in some new mobs. So I'm going to paste these into the workspace. Look at these, I've got 4 new mobs, well, 3 new ones. And here they are. We've got our zombie, who we've already met. We've got our noob character, who is similar, but I've modified his humanoid, and I've given him a little bit more health, and I've increased his walk speed. He's a bit faster. Then we've got this mech character, and he's sort of like a heavy tank. So he's got a lot more health, but he walks pretty slow. And then we've got, as our boss, of course, we've got Teddy. Now, Teddy walks even slower. He's got tons of health, so he's going to take a bit of killing. Now, all of these characters, if you want to use them, I've published them as a free mole, so you can go and take them. And you'll notice all of them, they have their own animations folder inside and the walk animation. Now, you can use whatever characters you want, but make sure that you have an animations configuration folder like this and an animation called walk inside it with your animation ID. If you are using mine, then the animations are all ready to go. Apart from the zombie and the teddy, you will need to publish the animation yourself, because this is just my animation. But you can do that easily enough. You see there's an anim saves folder. So if you click it, go in with your animation editor, select the rig, and then you'll see the animation will load for you. And all you need to do is publish to Roblox and then get the ID for yourself. So, with all that done, let's move all of these mobs now, grab that folder and move it into server storage, and we can get rid of that old mobs folder that just contained the single zombie, delete that. Now, the cool thing is, in order to just add these to the game, we've already done most of the groundwork, so I could just head into my main script here, and where I was spawning 3 zombies, well, I can just spawn in 3 mechs instead. So if I click run, I should hopefully see, here come 3 mechs, and out they come. They're moving a little bit slower. How about we spawn in some together? So we spawn 3 mechs and 3 zombies, zombie, not plural, is it? Zombie singular. And we run that, we get the 3 mechs, and then behind them the 3 zombies. Now we'll see, because the zombies are a little bit faster, they're actually going to catch up with the mechs, and they're going to kind of push against them. And obviously, this is not ideal at all. It's a bit of an issue, really. So how can we stop these collisions going on between our different mobs? Well, in order to do this, we'll stop the game. We're going to use something called collision groups. So if we go to the model tab on the top of our screen, and we'll click collision groups, it'll bring up a new window here. At the moment, everything in the game is under this default group, but we're going to add a new one in called mob. So right at the bottom, just type mob, hit enter, a new one appears, and you can see by default, it's going to be interacting with the default group. That means it will actually collide with the base plate and everything else, which we want, but we don't want it to collide with other things tagged as mob. So we untick that. And then we're also going to add in a player group as well, because we don't want our player to be able to run in front of the mobs and stop them from walking. So we want to disable collisions between the player and the mob. We'll untick here. And I guess we might as well disable collisions between each player as well. So we'll untick there. So we should just have our one column here, where everything will collide with the default, but they won't collide with each other. So once we've created those collision groups, we can actually close this window. And now we'll need to set it up in our script. So we'll head into the mob module script. And just after we spawn them in here, in the mob.spawn function, I'm going to need, well, first of all, I'm going to need the physics service. So actually, at the top of our script, where we like to put all our services, we put local physics service, and we'll make this variable equal to the physics service. Now we've got that, we can go down here as we were before, and we're going to need to set every single part within the mob to be part of this collision group. Because of this function, we want to use physics service set part collision group. That takes a part and the name of the collision group, which is the mob. Now, we can't just set it to the whole model. We need to set it to each individual part. So to do that, we're going to loop through them. For I object in I pairs, and then we'll do new mob, colon, and we'll call the get descendants method. Now, we don't want to use get children like we've used before. And the reason for that is because a child is just the top level, whereas descendants is everything, right? Children and sort of grandchildren, I suppose you can think about it. So if you're a bit confused by this, if you look at the server storage here, you'll see server storage has one child, which is the mobs folder. And then the mobs folder, if you open that up, the mobs folder has these other 4 children. But these aren't the direct children of server storage, right? Server storage only has this because it's one child, and then all of these together are its descendants. So we want to ensure we get everything regardless of the hierarchy. Once we've done that, we're going to check if the object is so capital I, capital A, is a base part. Because we're not interested in trying to modify any meshes or anything like that. We only want parts. Oh, I didn't put in if. If, then, new line, there we go. And then we can Control X, Control V, and we'll set the collision group to be that object. Set that object to be part of the mob group. And now, hopefully, once we've done this, and we rerun the game, there should be no more collisions. Let's see. The zombie should start to, there we go. They're moving through the mechs, and they're slowly going to make their way to the front of the queue. Perfect. And next up, we just want to add our player to the collision group. Because if I spawn in with my player, I can still walk in front of them, and obviously we don't want me pushing them out of the way. Don't want any unfair advantages. So we're going to create a... We could do this in our main script, but I think what we'll do is we'll just add in a new script for now. So brand new script into server script service. We'll just call this on player added. And so what we're going to need to do here is detect whenever a player joins. So we'll need the players service for that. Local players equals game get service players. And we're also going to need the physics service again. So you can copy that over from the mob module script. Copy that, paste it in. And now we will say players dot, and we're going to use the player added event. We can tell it's an event. It's got these little yellow lightning symbols next to it. Player added, and we'll connect that event into a function. And the function will give us player who has been added. New line completes that code block. But it's not enough to just detect when the player joins the game. We also need to detect when the actual character spawns in. So then we are going to use another event inside of this event. Player.character. Oh, I can't spell. Character added. And when this event fires, we're going to connect this to another function, which will give us their character. So we've got one function-driven event, or event-driven function, connecting to another function. So it's a function inside of a function, and then we're going to have the character. So at this point, we can copy what we did in our mob script over here, where we looped through them all. So I can select this for loop, Control C, go here, Control V, paste it in, and all I need to change is where it says new mob, I want to change it to character. So swap that in, and I need to change it from mob to the group we want, which in this case is the player group. So now when I play, hopefully I won't be able to now collide with the other mobs. Let's see. There we go. I can move through them all. Fantastic. Now, one other thing you might have noticed is when I get close to these and I walk away, there's a little bit of a glitch in the movement. Did you see that? They sort of judder forwards and then backwards. You might be able to tell that when I get close and then walk away. It's subtle, but it is a change that's there. And the reason for that is to do with how Roblox's network physics work. So when I get close to an object, the game assigns me network ownership of it. And when I'm away, it's just the server. And the little gap that creates is what creates this little sort of jitter in movement. Now, we want it to be really smooth, so we're just going to give the server network ownership all the time rather than allowing the player to have any. So to do that, it's actually really simple. All we need to say is we're going to go into our mob spawn function. And after we've set the parent to the workspace, and we just put new mob dot humanoid root part, which should be its primary part, and we use the set network owner function. And the only parameter we have to give is, because we want it to be the server, instead of putting a player, we just put nil. Nice and easy. And so now when we hit play, hopefully we shouldn't have any of that sort of jittering movement. Hopefully it's a lot smoother. There we go. Really smooth. And if I walk out and back in again, it's not going to make any difference because it's staying on the server the whole time. Much smoother. So now we've got these different mobs. What we really want to do is have some animations, because it all looks a little bit boring and lifeless at the minute. It would look much more exciting if these were actually animated. So to do that, we're going to create a local script, because we want this to be on the client or on the individual device rather than happening all on the server. So we go to starter player scripts, add in a local script. We'll call this mob animations. And then we're going to detect whenever a new mob is added to the game. Now I think at the moment, go into our mob script, we are adding our new mobs. We're adding them into the map. Actually, I'm just thinking now, instead of adding them into the mob, it would probably make more sense to add this mob folder inside the workspace. So I'm going to move this out of the grassland folder, which is the name of my map, into the workspace. And I'm actually going to rename it to mob with an S, plural. Then it feels a little bit more consistent. I like to have a bit of consistency. So we've got a mobs folder in server storage and a mobs folder in the workspace. That makes much more sense to me. And so now we'll set it to the parent to be workspace.mobs. And if we're changing that, we will also need to change our main script, won't we? Ah, yes, over here. Change it for it to be workspace.mobs. So now, once we've done that, we can go back into our local script. And we'll say workspace.mobs.child added. And we can connect it. And at the very top, we're going to create a function, local function animate mob. And the parameter will be the object that we want to animate. So we'll connect this event to that function we've just created. And now we're going to need to check that the thing that's been added into the mobs folder is actually a mob. So the best way to check is probably if it has a humanoid. So we'll get a humanoid variable equals object. And we'll do a wait for child, because remember, we're on the client, and when something gets added in the workspace, everything else inside of it has got to load. So if we just did .humanoid or find first child, it might return nil. Whereas if we do wait for child, it's going to actually wait a couple of seconds for it to load. It's probably only going to be a small fraction of time, but that fraction of time is important to ensuring that we don't have any errors there. We type the humanoid, and the next thing we want to do is check that it actually has an animations folder. Remember that little configuration folder I have inside of each of them? Down here called animations, and then I put the animation inside of it. We're going to check that's present. So that will be equal to object, wait for child again, and animations, which is what it's called. And so assuming that these are both here, we can then say if they exist, if humanoid and animations folder, if they're both present, then we can look for the walk animation. So the walk animation is going to be equal to the object, and we can do another wait for child again. So we'll copy that, wait for child, and it's going to be called walk. So if you've named your animation something different, make sure it's exactly the same. So mine is walk with an uppercase W, some wait for the child, walk with an uppercase W. So if there's a walk animation, Then we can start to load that animation. So the way we do this is we're going to get the animator object. Inside of each humanoid, there should be an animator present. So local animator equals humanoid. And we're going to do find first child this time. Find first child animator. And now sometimes your humanoids might not contain one. Or if you've got your own rigs that don't have them, you can just do this. So you can say it equals to humanoid find first child animator. Or if there isn't one present, if this returns false, then we can just create one. We can just create one right now. Instance.new animator, and then comma, and the parent, which would be the humanoid. Now we've created one instantly in the script. And now once we've got that animator, then we need to load our animation object into the to create an animation track. So walk track is the animator. We load the animation, which is the walk animation. And then once we've loaded it, all we need to do is we need to play it. Walk track, play. And let's just say, in case there isn't a humanoid in an animations folder, we could do an else down here. Else. And we could just do a quick warning down the output. We can say no humanoid or animation folder for, and comma, just put the name of the object. Object.name. There we go. So hopefully now, if I click play, we should have our animations working. Let's have a look. Oh, and look down here. We've got a infinite yield possible on mobs.zombie wait child walk. Ah, I see what's happening. Hit stop. And look, we tried to look for walk inside of the object itself. Whereas we need to look for it in the animations folder, don't we? So we're going to go to the animations folder and then look for the walk animation object. There we go. And look at our animations. Here come the mechs. Here come the zombies. Awesome. And if we want to see, what else shall we see? Go back into our main script. How about we load in some noobs as well? Actually, right beneath it, we can spawn in some noobs. We'll spawn in 5 of them onto the map. Play. Remember, the noobs are our fast characters, so they should run right through the middle of all of them and quickly sprint to the front. Here they come. Okay, this is looking pretty cool. I'm really liking where this is going. Now, for our actual game loop in general, we can start to flesh this out a little bit. I mean, I'll leave it to you guys how complex you want to make it, but I'm probably going to add on a few more waves. So we're going to create 10 waves, and we can start to change some of the rules here. Okay, so I've created a bunch new rules now. So we'll just read through these, you can see what I'm doing. So if it's the first 2 waves, so if wave is less than or equal to 2, so 1 or 2, then it's going to spawn in. Actually, we don't want a teddy. I want to have just zombies. There we go. I was testing it out earlier. Just zombies. And if it's less than or equal to 4, so wave 3 and 4, then we're going to have zombies and noobs. And that's going to be equal to whatever the wave count is. And then we're going to do that inside of a for loop, look. So it's going to be repeated 5 times. So on the 3rd wave, for example, it's going to spawn in 3, and that will repeat 5 times. So we're going to end up with 15 zombies and 15 noobs and so on. Then for waves 5, 6, and 7, we're going to introduce some mechs as well. And then for waves 8 and 9, we're going to have mechs, noobs, zombies, more mechs, and we're going to introduce a teddy. And then finally, on wave 10, we're going to have 1 zombie. We're going to spawn in a bunch of mechs, teddies, zombies, and then finally another 10 teddies. So things are going to get pretty busy around here. I mean, you can do whatever kind of logic you want, but I think this will do us nicely. Maybe we'll need to tweak it a bit as we go along. I mean, let's just play here, see what this is looking like. 3 zombies to start with. Okay, wow, that's a lot more units. I hope whoever's got their towers set up are ready for this. And as wave 10 rolls around the corner here, things are getting pretty wild, but hopefully your tower defense game is coming along well here, and it's looking as lifelike as this one. If you have found this helpful, then please leave a like, and why not even consider subscribing. Thank you very much for watching. Ooh, here's Teddy, and I'll see you in the next one. Goodbye!